Hello children, welcome to our class. Now the continuation of electromagnetic waves, in that the electromagnetic waves, sources of electromagnetic waves, the source, production in the nature. See, how are electromagnetic waves produced? See, neither stationary charges nor charges in uniform motion. See, that can be sources of electromagnetic waves. And we can say that how they are produced. See, e.m. waves are usually generated by, we said, the electrically charged particle that is oscillates. The electric field which associated with the accelerating charge, which is vibrates, generates and vibrating in the magnetic field. See, these both vibrating electric and magnetic field give rise to e.m. waves, that we say, right? Now, we can say the former produces only electrostatic field, while the later produces the magnetic field that we said. And what is the result, the important result of the Maxwell's theory, that associated the charges radiate electromagnetic wave, that he proved. See, the proof of this basic result is beyond, we can take it from the books and all, but we have to accept that on the basis of rough qualitative reasoning, right? See, consider a charge which is oscillating with some frequency. This produces what we said, an oscillating electric field in space, which produces an oscillating magnetic field and is a source of oscillating electric field also, we can say. See, the oscillating electric and the magnetic field regenerate. That only we said what? The waves are propagating. So, the frequency of the electromagnetic wave naturally equals to the frequency of oscillating of the charge. And the energy associated with the propagation of the wave comes at the expense of the energy of the source. That means the accelerated charge. Right. See, after Maxwell's point of view, Hertz successfully, he experimentally proved the test of Maxwell's theory, which created the sensational spark of other important works in the field. See, the two important achievements in the connection deserve mention in this. And after 7 years of Hertz, Jagdish Chandra Bose, he worked a lot and he succeeded the producing and observing the electromagnetic waves of much shorter wavelength, like 25 mm to 5 mm, right? So we can see furtherly about how Hertz experiment, which given and give rise and existence to the next part, right? See, he not only showed the existence of the electromagnetic waves, but also he demonstrated that the waves which have wavelength 10 million times of the light wave, right? See, it could be diffracted, refraction and the polarization, all the phenomenon of light. See, thus he conclusively established the wave nature of the radiation, and also he produced stationary electromagnetic waves and determined that the wavelength by measuring the distance between the two successive nodes. See, since the frequency of the wave was known, that is being equal to the frequency of the oscillator, he obtained the speed of the wave using the formula that is mu, which is equal to v lambda, and he found that waves travelled with the same speed as the speed of light. See, the fact the electromagnetic waves are polarized, that can be easily seen in the portable AM radio to a broadcasting stations. See, if an AM radio has a telescopic antenna, it responds to a electric part of the signal, right? So when the antenna is tuned horizontal, the signal will be greatly diminished. See, some portable radios we know that have horizontal antenna using inside the case of the radio we have seen, which are very sensitive to the magnetic component of the electromagnetic waves. See, such type of the radios must remain the horizontal in order to receive the signals. We may see that, right? Next, see, do electromagnetic waves carry energy and momentum like waves? Yes. See, we have seen in that chapter 2, that is the region of free space with electric field, right? Next, that electromagnetic induction, which we seen that it is associated with the magnetic field B, is magnetic energy density, also we have studied. See, as electromagnetic wave contain both electric and the magnetic fields. This you must keep it in your mind. There is a non-zero energy density which is associated with it. Now, consider a plane which is perpendicular to the direction of the propagation of electromagnetic wave. If there are on this plane electric charges, they will be set and sustained in motion by the electric and because of the magnetic field in the electromagnetic wave. The charges thus acquires energy and as well as momentum from the waves. So, this we can get it from the electromagnetic wave, which carries energy and as well as momentum. Since it carries the momentum, energy and momentum both, an electromagnetic wave also exerts pressure, that we can call it as radiation pressure, right? Now, we can say if the total energy transferred to a surface within the time t is u, it can be shown that the magnitude of the total momentum which is delivered to the surface, which is nothing but P is equal to U by C. See, we can take an example like when the sun shines on your hand, you may feel the energy being absorbed from the electromagnetic waves. Your hands get warm. Is it right? So, electromagnetic waves also transfer momentum to your hand. But because of the C is very large, the amount of momentum transferred is extremely small and you do not feel the pressure. Understand? The pressure which is also exerts, right? And you have to know about the great technological importance of the electromagnetic stem, that is from the capability to carry the energy from one place to another. The radio and the televisions from broadcasting stations that carry energy, right? The light carries energy from the sun to earth. So these are all making the life which is possible on the earth, right? So what is properties of electromagnetic waves we can see? See that properties of electromagnetic waves with the help of the diagrammatical explanation we have already seen. See that, but you can see the variations in both electric and the magnetic fields occur simultaneously, so that only they attains their maximum and minima at the same place at same time. Through the diagrammatical expression you can understand that clearly. The direction of the electric and the magnetic fields are mutually perpendicular to each other, and as well as to the direction of the propagation of wave. The electric field vector E and the magnetic field vector B are related by C, which is equal to E naught by B naught, and where E naught and B naught are the amplitudes of the respective fields, and C is the speed of light. In the previous video we have given and explained about one of the point of the properties of electromagnetic wave. See, we can say the velocity of electromagnetic wave in free space C which is equal to 1 by root of mu naught and epsilon naught. The velocity of electromagnetic waves in a material of the medium which is equal to 1 by root of mu c. That we know that mu and epsilon are absolute permeability and the absolute permittivity of the free space or material of the medium. So electromagnetic waves is always obeys the principle of superposition. So because of that, the cross field it is working, the electric and the magnetic field, automatically it must obey the principle of superposition. So electromagnetic waves carry energy as they propagate through space. This energy which is divided equally between electric and the magnetic field. The electromagnetic waves that can transfer energy as well as momentum to object placed on their path. For discussion of optical effects of EM wave, more significance is given to electric field E. Therefore, the electric field which is called as a light vector. The electromagnetic waves do not require any material of the medium to travel. An oscillating charge which has non-zero acceleration can produce the electromagnetic waves. See, Hertz experiment. See, usually Hertz used an oscillatory LC circuit for producing the electromagnetic waves. See, the transmitter which consists of two large square metal, that is brass, the plates with sides of 40 to 60 centimeter. See, these are placed in the same vertical plane which are about 60 centimeter apart. The plates are connected to two thick wires ending is highly polished brass spheres which is S1 and S2 which is there. See, the distance between the two spheres is between 2 to 3 centimeters only. The two thick wires are connected to the stationary terminals of an induction coil. See, every time the current in the primary circuit of the induction in inducing the coil is interrupted, a large potential difference is set up across S1 and S2. See, and the metal plates get charged that time. The high PD, that is potential difference, ionized the air in the gap and makes the gap conducting. See, the electron and ions so produced oscillates back and forth across the gaps between the S1 and S2. An oscillatory that charges of the plates occurs through the conducting gap. This process only gives the results to the production of EM wave. See, the metal plates from the capacitor of low capacitance C and it is connecting wires offers low inductance L in the system, so that the system which generates EM waves of high frequency, right? So that is V which is equal to 1 by 2 pi root of LC. So the receiver or the detector which we said consists of almost closed circular stout, we can say the wire, right? So these are all the points what we have given for the Hertz experiments. See, due to the high voltage, the air in the small gap between the spheres get ionized, right? So what we, through the experimental device what we explained, the points which I have given for you, you can take the notes for your experiment. See, it was observed that the spark was most intense when the spheres S1 and S2 were parallel to each other. S1 dash and S12 dash both is parallel to each other. This was very clear evidence of the polarization of the electromagnetic waves. So one of the important point, the next one is Hertz was able to produce the electromagnetic waves of the wavelength nearly 6 meter. After his all the studies regarding the electromagnetic waves, the 7 years, J.C. Bose, he succeeded in production of the e.m. wave of wavelength ranging from 25 millimeter to 5 millimeter. See, right? Thank you, children.